Okay. Good evening, everyone. Welcome to the summary session for the course on regression analysis for this year. I'm Shreya and I'll be talking about how to solve a few problems. So, I had initially planned to solve assignment questions from week 9 to week 12, but just 10 minutes ago, I think you guys received the solutions. But nevertheless, I'm still going to do that and explain each step as I go. But before doing any of that, please let me know if the screen is visible and if I am audible or not. And even if you have any doubts, just let me know based on the entire course. Hello, you're not audible. Can you please speak louder?
Ma'am, I have a doubt.
Yes.
Ma'am, can we use the general formula of binomial distribution or the formula which you have taught?
What do you mean by general formula?
Actually, I have also made some notes.
Okay. Can you tell me right? Can you write it down, or I'm not able to understand what you mean by general formula. So
Ma'am,
by
we have exponential family distributions
yes, yes.
in which f of x given k equals to h of x, exponential of h of n of k
Hmm.
tx minus a of k. And we have also another formula f of x where exponentiation of theta x minus b theta by a phi plus c x phi. I have checked it from Google. Like there we have another formula. So the formula which I have told before is a generalized more formula or which formula we have to use more often in solving question.
Okay. So when you have some probability related questions that, let's say I have something like this that uh, okay, I'll if you please let me know if you can see my screen. Okay.
Yes, ma'am.
So
Visible.
if the question is of this sort, that let's say something follows a Bernoulli. So let's say this one, let's have a variable x, which is like number of, let's say we are tossing a coin 10 times, okay, and we say that tail is a success, okay, and if your random variable is number of successes in n equal to 10 trials, here your trial is toss, okay. If this is your random variable and if you have something like this, that find probability x equal to 10 or find probability x greater than 5 or find probability x less than equal to 7, if you have something like this, then what you should do is you should use this formula ncx p to the power x and 1 minus p to the power n minus x. This is your probability x equal to x. Alright. So if you have questions of this sort where you are asked to find out probability of some binomial variable or some exponential variable or anything, then you can use this formula. Whatever, now this one is actually nothing but the PMF of this distribution, okay, probability mass function. So
Ma'am, as of question number 4 in assignment,
okay.
of week 12,
of week 12.
we have asked
And
to check that is it exponential family distribution or not? Like, is it belongs to
this
exponential
one.
family or not? So, for solving this,
Yes.
which formula? Like, can you elaborate it?
Yes, of course.
Like,
So, if I go back to what I was saying, so this is how the probability distribution looks like. Now, if we can map this distribution to that e to the power form, then we can say that this family belongs to that exponential family. So if I go to question number 4, I'll solve it here. Okay, if please let me know if this is your question or not. Okay,
yes, ma'am. That's
this one, no? Okay, so now if this is fxk, this is 1 by 2 to the power k by 2 gamma k by 2 x to the power k by 2 minus 1 e to the power x minus x by 2. Okay, so if we write it as exponential, we can write it as exponential into log of the entire thing, right? So
yes,
what
ma'am.
we, okay, so then first step is whatever pdf you have, you do exponential and log, and then 1 by 2 k to the power 2 gamma k by 2 x to the power k by 2 minus 1 e to the power minus x by 2. All right, now just expand this. We have to match it to that exponential form. All right, so here we can write it as exponential log of okay, so this one, log of 1 by 2 to the power k by 2 gamma k by 2, we can write it as minus ln 2 to the power k by 2 gamma k by 2. Okay, then we can write it as plus k by 2 minus 1 into x. Okay, and then again log of e to the power minus x by 2, so that is nothing but minus x by 2. Okay, so here we have exponential minus ln 2 to the power k by 2 gamma k by 2 plus k by 2 into x minus x, something like this. So if I write it as exponential a
Ma'am, we will have x by k by 2 ln of x, no?
ln of x,
Like
yes,
if
k by
I
2
put
ln of
ln
x,
a
yes,
by
yes,
b,
of course, this is ln of x. Thank you. K by 2 ln of x minus x. So if this is ak bx plus ck plus dx, here the parameter of interest is, let's say, k. So then ak will be something which is with, we have to find out, look for areas where k and x come together. So ak will be k by 2, bx is ln x, ck is this log function minus ln whatever, this one, this star term, and then dx is again minus x. So you see this pdf is mapped to that exponential form. So we can say that yes, the answer is yes, it belongs to the exponential family of distributions. Okay, now is it a canonical form? For it to be canonical form, bx should be equal to x, but here
ma'am,
it,
is there a general expression that you wrote a k bx
yes,
c k dx?
yes. So if any pdf, if any fx can be written in the form of expression e to the power a theta, where let's say this is your pdf or probability distribution, theta is the population parameter of interest. Okay, so if you can write this as e to the power a theta bx plus c theta plus dx. If the PDF can be transformed into this form such that a theta is a theta parameter containing term solely, bx is a observation containing term, c theta is again only parameter, dx is again observations. You could have nuisance parameters, other parameters, say z, gamma, which are not the parameter of interest for this sake, in any of these. Okay, that could also be there. But if you can write the distribution in this form, then we can say that this x is belonging to the exponential family of distribution. Okay, so then we say x belongs to exponential family. This
Ma'am, actually,
yes.
sorry to interrupt. Ma'am, actually, I have seen a formula.
Okay.
Fx equals to exponentiation of x theta minus b theta by a phi plus c x phi. If I have to find the expectation, mean, variance, I can just find the derivative of b theta. And if I have to find the variance, I can just find a phi d square by d theta square. So is there any formula? As I have seen this formula on my Google, as I searched
Okay.
that.
Okay, yes.
But can I also use similar formula like to find
Yes,
expectation, natural term?
you were telling me, just tell me what formula you have seen.
Exponentiation, theta x
Theta x, okay. Theta
times x, theta times x,
okay,
minus
minus
b of theta, denominator a phi, a of phi, in denominator, whole denominator.
Okay, this
whole denominator, a of phi.
Okay.
Plus c x phi, c of x phi.
Okay.
Yes. Okay. And if I have to find the expectation, then I can just find delta b theta of delta del theta. So I will get expectation. And if I have to find variance of the function, the PDF function, I can just find a phi del is double derivative of b theta in respect of theta. So in respect of b theta, I can find expectation, that is mean, and variance also. So is it valid?
So this one is it some specific distribution, or you found this form in the?
This is a generalized formula. I have seen, I have searched on internet, and I can easily figure out that is it canonical form, or I can find the expectation, mean, variance, e of x square, and any other parameters of PDFs. Just using this parameter, I have to just rearrange my expression in the form of this, where theta is a function and x theta is a population parameter, as you told, and c of x phi is a constant and a of phi is a constant. So as if you solve question number 1, so where we have question lambda power x e to the power minus x factorial in denominator. So we can expand it as fx equals to uh, like that, and we can easily find like the mean would be e of theta and the variance would be e of theta of question 1.
Okay, so
we can easily.
So why don't we do something? See, I have not I am not aware of this formula, to be very honest. What I want you to make sure is that, see, exponential distribution and exponential family of distribution is a little different. Okay, so this one, are you sure that this is the formula or form form of exponential distribution? Because it could
Yes, ma'am.
be. Okay.
Yes, ma'am. It's the formula of exponential family to check whether an exponential function belongs to the family or not. We can write it in the form. If not, then it is not written also in canonical form.
So this one is only to check if it's in the canonical form or not, right?
No, ma'am. It is to check that it is of exponential family or not. Yes. And using that, we can find the other parameters by just seeing this expression.
But from what I I'm observing. So if this b theta equal to theta means that it's a canonical form, right? So if I try to map this with the generalized form that I know of, then b theta will always, sorry, this is something b theta solely depending on theta. So let's say this is that ax into d theta, some x and theta containing terms together. So here we see that d theta is equal to theta. So I have a feeling that this could be used to test whether I mean for only those distributions where where it, I mean, it follows the canonical form. So one easy way to check this would be uh, just pick any random distribution and where we already know that it's in its canonical form. Okay, and then uh, just apply this formula and you check whether the expectation and variance whatever they have mentioned, are they matching or not.
Okay, ma'am.
Okay, so because I am not aware of this form, I won't be able to tell you, but my intuition is this could be the uh, this is not the generalized form, but only to check if a distribution which belongs to the exponential family is in its canonical form or not. If it is in its canonical form, then maybe this is applicable. But since I'm not so sure about this, I would ask you to do this. You pick any distribution, okay, in its canonical form, and then you apply this formula and then apply whatever p theta, the expectation and variance of this is. And if we know that that is the thing, then we can very well go ahead and do this.
Okay, ma'am.
Okay, but since I'm not aware, if you can send me this link in the post, I maybe I can check.
Okay, ma'am. There's a playlist on YouTube where I've
Okay.
studied. Ma'am, I've sent the link.
Okay.
So,
Okay. So I'll just see and just I'll stop the screen share for something else. Let me know if you can see my screen. So is it visible?
Yes, ma'am. Screen is
Okay,
visible.
okay.
so today we're going to look at how to needs to be
So he's checking
rewritten
the
into
question.
this form.
Okay, so this is natural exponential family. Okay, not the general form, I think. Natural exponential family, I think they mean canonical. Natural exponential family. Special case of an exponential family. Okay, see, what we are using is actually this formula. This is the generalized equation where we have eta theta into tx, where t is actually the sufficient statistic. Okay, now I don't think we have discussed this here. And if we have a natural parameter with parameter theta, that is, if we have a canonical form, then we are using this hx equal to exponential theta x minus a theta. So eta theta is replaced by theta and tx is replaced by x. Do you understand? As I was saying, this is only valid to check whether it belongs to the canonical form or not. So the distribution that they have taken over here, so see,
Poisson distribution.
this is a Poisson distribution, and then they are writing it the theta equal to log lambda, and lambda equal to eta theta. So beta theta is eta theta. This is this. Okay. So expectation is del theta of b theta. All right, which is lambda, and d square. Okay, a phi. This is this thing. All right. I see. But anyway, these things also I think we can use, but we have to be mindful that it is it belongs to the natural exponential family. Okay. So if we try this with binomial, let's say, will we have the same results? Let us just check. So here binomial probability is ncx p to the power x 1 minus p n to the power x, p by 1 minus p x 1 minus p to the power n. So this would be exponential ln of ncx plus x ln p by 1 minus p plus n minus 1 ln 1 minus p. Okay, so then a theta would be this ln p by 1 minus p, then bx is x, cx is how much? Okay, so this is theta into x. Okay, no, so theta is ln p by 1 minus p. Alright, so here we have exponential theta x minus b theta by a phi. So what will be b? A phi is 1, I think. A phi is 1, and we have b theta as this thing, n minus 1 ln 1 minus p, and plus, okay, here what do we have? Plus cx phi. So that would be plus ln n cx. So theta x minus okay, so this will be 1 minus n, I think. And now what are they saying? What is the expectation of x is how much? dd theta of b theta. So dd theta of b theta is how much here?
1 minus n ln of 1 minus p.
Okay, so theta is ln p by 1 minus p,
and b theta equals to 1 minus n ln 1
b
minus
theta is 1 minus n ln 1 minus p.
1 minus p.
Okay, so d theta of b theta would be 1 minus n into 1 by 1 minus p into minus 1. So that would be minus n minus 1 by 1 minus p. So this is not matching actually.
Then how are you taking the differentiation then? Theta would be ln p of 1 minus p. So b theta would be differentiated by comparing ln of b1 minus b. No? You are generalizing it.
No, the if the what did they mention over here? So it's theta x minus b theta, right? So theta is this thing. If we compare with this form, x and p containing term should be theta. So
Hmm.
ln p by 1
Theta
minus
x.
p is theta minus some on the sole parameter of b theta. So this is this. I don't think this will work because if we see, this is not a natural it is not in its natural form. So our interest is p, parameter p, but the canonical form is ln p by 1 minus p. Okay, so if it is not in its canonical form, I don't think this is going to work.
So over here, the more general formula that we have taught, we have to use it.
Yes, it's preferable you use this formula. Use this, and then just if it maps, then yes, it belongs to the exponential family, and from there we can always deduce uh, whether it's following a canonical form or not, given that whatever is occupying this theta and x containing term, if b of theta is okay, so here should be a theta bx. So if a theta equal to theta, we can say that it's in its canonical form. Alright, because that's a specific case, I don't think everywhere it is going to work.
Okay, ma'am.
Is it okay? Alright, anything else?
No, ma'am. I will be.
Okay, any other
Ma'am,
doubt? Yes.
actually, I've solved every question
Okay.
of assignment 2.
Alright.
Just I have that confusion like we have to use natural exponential family or general, which you have already resolved.
Okay.
Ma'am, why we what is the significance of canonical form? Can you tell me in just some words?
So if you have I'm not so sure about the significance in the larger scheme of things, but if you have that theta x form, so if you see here, what you should note is that there is something called a sufficient statistic. Okay, so the idea behind this is that we want to so the concept behind sufficient statistic is this, that let's say let us define a statistic called t. All right, so this is a function of only the observations. Okay, and this is not dependent on theta. If you can find that something like this, then this thing is usually called as a statistic. All right, now if a distribution, it belongs to the exponential family, and we can write it in this form, that exponential of eta theta tx plus c theta plus dx something, then tx is usually the sufficient statistic for eta theta. All right, so if tx equal to x, then x would be the sufficient statistic for theta. All right. So I think that's the thing that's the significance of having it in its natural form, because it's
And ma'am, over
easier.
here, HX, where is HX? Because as you have all seen on the website, there is the HX term, HX,
Hx,
after the
no?
exponential.
Yes, so if you just, so exponential of, if you have hx over here, if you want to keep it inside, all you need to do is, one second, hx into this thing, right? So if you have exponential of ln hx e to the power eta theta tx minus a theta. Okay, so this will be exponential of ln hx plus eta theta tx minus a theta. So this is the same thing. I mean, if we map this with the form that has been discussed so far, then a theta bx plus c theta plus dx term, whatever you have, that is actually ln of hx. Okay, so these are equivalent, but again, this is the natural parameter thing. And I was talking about sufficient statistics. So sufficient statistic is that if you given t, f of x1 to xn will be independent of theta. Okay, so what it essentially means is that once you have compressed the data into some condensed form, this statistic is enough to explain the distribution. We don't need anything apart from this. If we have f of x1 to xn given t independent of theta, so t is a function of the observations only, where we are sort of collapsing all sorts of information on this variable, on all the n variables into a single variable, and that will serve the purpose of let's say data reduction in future cases. If we have to store if we have to infer about this population parameter theta, instead of storing n variables, I can combine those n variables into a test statistic and store that instead, because given that, we can infer what should be theta from that statistic only. Okay, so I believe canonical forms are useful in that case. Usefulness of, let us just check, canonical forms of exponential family. Yes, mainly for calculations and easier to work with. See, exponential family, okay, yes. Yes, we can use this form if we want to simplest representation of an object allows it to be identified in a unique way. But I don't think this is unique. Anyway. Okay. Anything else that you want clarification on? I hope I was able to, even if partially I was able to make
No,
myself
ma'am,
clear.
I have understood what I was.
Okay, okay.
I have understood it.
Okay, thank you. Anything else?
No, I am going through my assignments,
Okay.
like checking the solutions. We will go into.
All right, all right. So I'll also go through the same. So just if you want to check that out, then it's fine. And any other doubts also, if you have in mind, please let me know. And just excuse me for a second. I'll just get my charger.
Ma'am, actually, there is no student in the lobby.
Okay, but anybody can enter this. It's open. I don't see anyone. Do you see anyone else?
No, ma'am. Actually, ma'am, this course is a bit difficult. That's why.
Can you please repeat? Sorry.
Actually, this course is a bit difficult.
Okay. But why do you think so?
Because there is so much of statistics, so much of distributions to memorize.
Uh, yes, but I don't think you need to memorize too much. But the only thing that, so for this exponential family, you just have to remember that form. Okay, generally speaking, what difficulties did you face in this course?
Ma'am, initially, as I have started learning, like the initial lecture like linear regression, simple linear regression, multiple linear regression, where I have just learning normal distributions in which y equals to mx plus c, the extended version of y equals to mx plus c, multiple linear regression was easy.
Okay.
After that, checking best regression model and checking other forms, regressors, how they're dependent, weighting and correct model, like their transformations. So all of that getting tedious.
Okay. Yes, I can understand the transformations part is a little heavy, but yes, but so one good part about this thing is that there is a general formula as well for that transformation thing. So if you can remember, like for ease of calculations, I'm saying, if you see standard distributions, then maybe you can just memorize the table that shows what distribution to. So for example, if you have a Poisson distribution something, then the transformation would be square root of y, right? So these things actually, with practice and enough use, it might seem very heavy once you are learning it, but once you move on and go on to apply, then I think it will be easier. Okay. Conceptually, anywhere if you have faced problem, please let me know. I will try to make it easier.
Ma'am, multicollinearity, can you explain in very
Okay.
short, like
Yes.
major points in multicollinearity, like checking that is there any multicollinearity exist or not?
Okay. So, multicollinearity.
Between two independent variables.
Yes. So it could be of two forms. It could be exact. It could be near perfect. All right. So exact means what? That one column, let's say if this is your X matrix, let's say this is your model y equal to x beta plus epsilon, and this is actually the model.
No, your screen is not visible.
It's not visible? Oh, I'm sorry. 1 second. Can you see this?
Yes, ma'am.
Okay.
Please.
Yes. So multicollinearity can be of two types, okay? One is exact multicollinearity and the other one is near perfect. Exact one means what? If you have, let's say, this one is usually your intercept term. So this column will be 1, all right? And let's say this is your x1 variable, this is your x2 variable, fine? And I have something like this: 5, 7, 9, 1, 3, okay? And let's say this is 11, 15, 19, 3 and 7. So now you see, if we have to find out beta, then we have x transpose x inverse x transpose y, okay? This is the OLS regression. In order to do this, rank of x should be equal to 3, right? In order to have this inverse. Is it clear up until here?
Yes, ma'am.
Okay. Now for here you see there is an exact relation between x1 and x2. So if you do 2x1 plus 1, then you are going to land up at x2. So this one is actually an exact linear relationship. If we have something of this sort, then if we go do x transpose x, then rank of x transpose x or rank of x in this case will be equal to 2, which is less than 3. So this invert thing is not possible. So if you see an exact this thing, then you will not be able to find out beta hat OLS using the using this inverse function, because this inverse will not exist in that case. But usually what happens is we don't have this exact relationship, but we have something such that correlation between x1 and x2 is very high, okay? Correlation is what? It is a measure or metric of linear relationship between x1 and x2, right? So you will find, if you find out correlation between x1 and x2, if this will be exactly equal to 1, but even if you find something close to 0.9, let's say, that means it's very, very high. Now if we have high multicollinearity, then there are certain problems associated with this. So we have in those cases we have to tackle multicollinearity. The ways to tackle is that, since this is a sample phenomenon, if I add one more, let's say 1, 7 and 6, if I append another sample information, then you see this pattern is getting broken, all right? So that it's you have to remember, it's a phenomenon dependent on the sample. So based on how you are conducting your sampling and how you are getting it, a lot of multicollinearity will depend on that. So it is also known as a sample phenomenon, all right? Now other problems associated with multicollinearity are that you will have let's say, if when you are testing hypothesis h0 versus h1, you will have higher error rates, okay? In the sense that whatever you'll be rejecting h0 falsely, let's say, or if you are estimating some theta, okay? So let's say confidence interval estimation. 1 1 second. If you are estimating confidence interval, that theta is contained in this interval a1 and a2, or we should write a1 a2 contains theta. If we have multicollinearity, then this length will be more broad. Okay, what do we want? We want precise estimates, right? If I am trying to predict something, let's say this is the population of my interest and this is some sort of sample that I've collected. Based on this sample, I just want to infer some population parameter. Now I want my estimate to be as close to the true parameter as possible. So in that case, what I want is I should be 95% confident that my theta is belonging to, let's say, some 1.2 to 1.3. Okay, but if we have multicollinearity, it can happen that I can say with 95% confidence that theta will belong to, let's say, 0 to 2. So by default, if I say something like this, I am being more precise with my estimates, right? And if I say something like this, I am being a little vague. So if theta is belonging to this confidence interval, if the, let's say if I have theta equal to 1, I am testing this hypothesis. Okay, so 1 is belonging to this confidence interval. So if I am basing my hypothesis on this, then I should accept H naught. But if I am being more precise and if there is no multicollinearity in the data, then my theta will range between 1.2 to 1.3. Now 1 doesn't belong to this interval, so actually we should reject. So this is the true scenario. We should have rejected theta, but instead, because of multicollinearity, we are getting broader confidence interval. We are wrongly accepting something which is not true. Okay, so these are the problems that could arise if we have multicollinearity in the data set. So that is why it is important that we take necessary steps to remove multicollinearity from the data. So one way to do that is, if we have 2 or 3 variables which follow this exact same pattern, then the best way to go about is dropping variables, right? So if we take x1 only, then this will have rank 2. There will be no problem in getting the inverses. This is exactly the reason why we use lesser dummy variables when using categorical variables. For example, let's say if x is something like this. So let's say I have a variable x which is actually gender. So it could be 1 or 0. Let's say male and female, something like this. Okay. So if we have two dummies, let's say d1 and d2, such that if we have 1 0, then so if we construct dummies like this, dy equal to 1 if I equal to male, and d2 equal to 1 if I equal to female. So if I have something like this, let's say this is the intercept term 1 1 1 1 1, and this gender is now split into two columns, d1 and d2. Now let's say this is male, this is female, this is male, this is male, this is female. Alright, so then wherever we have males, d1 if we put 1 0 1 1 0, and in d2 wherever we have females, we put 1, so 1 0 0 1. So here you see, if we do d1 plus d2, then I am getting it exactly equal to the intercept term. So this matrix again, X will not have rank equal to 3. So what do? We keep the intercept term, we exclude 1, and we say that this is sufficient because this coding 1 0, if it is male it's 1, if it is female it's 0, this is sufficiently capturing the different categories. So I don't need another second category to designate females. And so this is how we are this is why also we are using lesser number of dummy variables than the number of categories. Okay, so if we have 3 categories, let's say education as well, okay, low, middle and then high school. Okay, this is primary, let's say primary school, this is middle school, this is high school. So if we characterize it into D1, D2 and D3, then again if we have intercept like this, D1 is if anybody has attended primary school. So okay, so let's say 1 1 0 0 0. Again if D2 I say somebody who has attended middle school only will get 1, so it will be 1 1 0 0. And then D3 is let's say 1 1 0 0 0 0. Again the same thing, D1 plus D2 plus D3 will be equal to the interceptor. So we don't need it. What we are doing, we are dropping any of these. Let's say we are dropping D3. So then D1 and D2, this combination will have, it could be 0 1, it could be 1 0 and it could be 1 1 or something like that. It could be 0 0, let's say. Let's have it 0 0. So it's that if D1 equal to 1 if primary, 0 otherwise, D2 equal to 1 if middle, 0 otherwise. Then 1 1 combination will not happen because it's actually exclusive events in exclusive categories. In that manner we should consider it in that way. So 1 0 will mean that this individual has attended primary, 0 1 will mean this individual has attended middle, and if we have both the things 0, then it would mean that this person has attended high school. So using two variables we are able to capture with their combinations the 3 different categories, keeping this in mind that this does not this does not violate the collinearity norms here. Alright, which of the following is not a plausible remedy?
Yes, ma'am. I have sent a question, ma'am. Which of the following is not plausible?
Not a plausible for near multicollinearity. Take logarithms of each variable. See, principal components analysis we can use to transform it into a space which is orthogonal and will not have multicollinearity. Drop one of the collinear variables, this is fine. Use a longer run of data. Take logarithms of each of the variables. Near multicollinearity, if you take logarithms, how do they fare?
Ma'am, actually, this is a question of assignment. The answer is take logarithm.
Yes, that's what I'm thinking.
How?
Because principal components analysis is going to do that. Principal components, if you have, very briefly, let's say you have certain x1 and x2, and graphically if I have to demonstrate, if this is your point on the x1 x2 frame, what principal component is doing is that it's actually rotating the axis. So what ultimately you are going to have is actually some axis of this sort. Alright, where this would be PC1 and this would be PC2, and the angle between them would be 90 degree, which means that they are orthogonal and independent of each other. So principal components is one way which removes multicollinearity in the data. Dropping one of the collinear variables is also again another choice, like I mentioned. Using a longer run of data, again, as I mentioned, this if you add sample, maybe this is going to break. It may not, but it may break. Taking logarithm, on the other hand, might not work. This is the reason why. So you see, if let's say, how does your y equal to log x look like? Ln x. So this curve will look something like this, right? So now if you have, say, your x values over here, so if x is 2, 3, or something like this, 1, 2, 3, 5, something, x1 and x2, okay, 4, 6, 3, 5. Alright, if you do a log transform of this thing, then also these points will lie very, very close to each other, right? So this may work, this may not work as well. Alright, so the other two examples that we have seen, principal components and dropping one of the collinear variables, these two will definitely work. Now taking the confusion is between a longer run of data and logarithms. So even we have seen that if we take since these are not cooked up data, real data is usually, if we take longer runs and if we include more samples, this collinearity will tend to get weaker and weaker if it exists. But in case of logarithm, if you see, if you just take logarithms uh, in very close space, so let's say these two are very close to each other, okay, these two x values, so their corresponding log values will also be quite close to each other, right? So then this mapping will automatically translate, or how should I mention, so if we have some pattern between x1 and x2, then taking logs, uh, I don't think that is going to help too much. For example, if we have, let's say, log of, if we have perfect collinearity in that manner, whatever we had over here, let's say y x2 equal to 2x1 plus 1. So if we take logarithm, so it would be log x2 equal to log of 2x1 plus 1. Okay, so if we can ignore this plus 1 because this seems to be like a little quantity, this is actually log of 2x. So that is log 2 plus log x1. So see, here again we are almost getting some sort of a linear pattern. Do you I mean, can you understand this part?
Yes, ma'am. Yes, ma'am.
So
Like
this,
the three options are plausible remedy, but this thing
yes,
is not
but this one,
a remedy to
if
solve this.
it's not exact. If I write it in this manner, then we cannot just ignore plus 1. But since this plus 1 is a small quantity, log of 2x, this linear pattern is again replicated in this sense. So if we have high collinearity between x1 and x2, it is possible that log x1 and log x2 will also be highly correlated. So it's not a possible remedy. All right, any other question?
No, ma'am, as for now, I have no question. Just
Okay.
remaining problems of week 12 assignment.
Alright, so do you want me to solve week 12 problems?
Yes, ma'am.
Okay. So this one I am not solving because this one was already given in lecture notes. I hope you could understand that.
ln y of 1 by 1 minus 5, just solving by expressions that we have discussed. Do that, I think.
Sorry?
This would be answer C, ln y of 1 by 1 minus
Yes,
5.
yes. Because this is actually binomial ratios. Okay. And we have seen that this is a constant, Ri is the number of successes, then this would actually follow a binomial distribution, and then that b theta form would be ln p by 1 minus p, so the choice of fy would be ln y by 1 minus y. So yes, this is the correct answer. This one, is this density a member of the exponential family? Yes.
Ma'am, yes. Ma'am, actually, I have solved it using natural exponential family. But using exponential family, I think I can also solve that.
See, if it is natural, then it belongs to exponential family for sure, because natural family is actually a special case. But the converse is not true. Okay, so if you could find that there is this distribution actually belongs to the natural form of exponential families, then by default it is actually a special case of the exponential family. So we don't need to do that cross check again and again. But if it belongs to the exponential family of distributions, it may or may not be of the canonical form. Alright, so this thing will only hold when we'll have the the functional form, or rather the that when that form matches and we would have b theta equal to theta. Okay, so this is another thing. Fine, so going ahead, this one, is this density in its canonical form?
Ma'am, no, because it is the form of 1 plus theta. So if I solve it, it will not come up with theta x form.
Yes,
Theta x of theta.
exactly. So this would be ln theta x minus 1 plus theta. So this would be exponential ln theta minus 1 plus theta into ln x. So then this would be exponential ln theta minus ln x plus theta ln x. So is this in its canonical form?
Ln theta. Ma'am, because x is in the function of ln x, but we want theta x. Theta of x. That's why.
Yes, so
Actually, I was comparing with theta x, and in which I only want x. So I can easily compare like theta ln of x. So theta f of x. So by comparing with natural, which I have been using, so
I
using
see.
that I can say that it is not. And also
All
the
right,
answer is correct.
but if yes, but if we use the generalized form, then what is the definition of canonical? How do we say that it's canonical or not?
First have to check no that is it belongs to exponential family or not. Then
Yes,
after
so
that we can check.
if we have this the x containing term, if it belongs bx, if it is equal to x, then we say this is in the canonical form. based on the form that we have discussed so far. So here you see bx is what? It is actually ln x. So this is not in the canonical form. The Poisson example that we were talking about here, you see it's in its canonical form because here x into log lambda. So theta could be log lambda, but bx is only x. Since this was in its canonical form, we could write it in this format and use expectation and variance in this manner.
So for for canonical form, bx should be equal to x.
Yes. If we have like this, e exponential a theta bx plus c theta plus dx, then bx equal to x would mean that it's in its canonical form. Okay, and then if this is in its canonical form, then a theta is actually the natural parameter. Alright, so in this Poisson example, log lambda is the natural parameter.
What was a theta, ma'am? What was a theta?
A theta, if bx equal to x, then a theta is the natural parameter.
Okay.
Okay. So
actually, I'm side by side. I'm taking notes. That's why.
Okay. So here, if you see this Poisson example, here also see x and lambda containing terms. The x term is only x, so it is in its canonical form, and the natural parameter is actually log lambda. Okay. All right. So if we go to binomial, then what will be the natural parameter in that case? Binomial is ncx p to the power x 1 minus p to the power n minus x. So this is exponential ln ncx plus p by 1 minus p x ln p by 1 minus p plus n ln 1 minus p. So this one, is it in its canonical form? Yes. What is the natural parameter?
b of
natural
b of x is equals to x.
Sorry?
Because b of x equals to x
yes,
over here.
b of x equal to x. This is x containing term. This is canonical. And natural parameter is ln p by 1 minus p. Okay. Just because the notation that I am using and in the notes is a little different, there could be some confusion, but just to make my point clear, if we have an x containing observation containing term and a parameter containing term together, if the observation is x itself, then we say it's canonical, otherwise we say it's not. And if it is in its canonical form, then whatever is form of the theta, the parameter of interest, whatever form we have sitting just close to, multiplied with that x, that is actually my natural parameter.
Okay.
Okay, fine. So, all right. Okay. So if I go to this one, here what is this? Consider the density function with parameter k. The natural parameter is what? So here you see, have we done this?
Actually, fourth question you have missed.
We've missed fourth.
Actually, we have done.
We have
over
done,
here.
no? So yes, so this
Subsequent
one,
of four question. So using fourth question, we can solve fifth because we only want to get the natural term.
yes.
So
So
the
fourth
solution of
question we solved it here, and then we got it that bx equal to ln x. Something we wrote it here, right? No, it should be
k by 2 minus 1, man. In above expression, k by 2 minus 1 times x
yes,
minus x by 2. K by
exactly.
2 minus
So
1 will
from
be.
here we can see that ax equal to, but here I think we have made some mistake. This shouldn't have been ln x. This should have been only x. Yeah. So this is the thing. Here we have k by 2 minus 1 and x all together. So this is in its canonical form, and natural parameter is k by 2 minus 1. Where is that? So this is actually k by 2 minus 1. Okay, moving on to the next one. This is a negative binomial probability mass function. What is the natural parameter? So from here also it's evident that this will have a canonical form.
Ma'am, what is negative binomial probability in short?
Negative binomial example. One second. Negative binomial. We'll just find out. Yes, number of failures in sequence of independent Bernoulli trials where before a specified number of successes occurs. Yes. So if you see this one, modeling such situations require a negative binomial. So what happens in binomial is that the number of trials is fixed. Okay. In negative binomial, we are fixing, we are modeling number of successes or failures, or rather we are modeling number of failures before x number of successes occur. Okay, so in broader context, if we have binomial, the question is n is fixed, that is the number of trials, and we are getting the number of successes or failures. Okay, if we have geometric, question is number of failures before first success or number of trials before first success. Okay, and negative binomial is actually an extension of the geometric distribution. So negative binomial, what we are saying number of failures before our successes. And how is it not related to binomial? Because n here is not fixed. Okay, so if the question is that how many times, what is the probability that you have 6 heads before 10 tails have shown up, that distribution would be a negative binomial, and it would have a form of this thing. Okay, so r successes and x number of failures, and then this would be the number of ways we can choose that. All right, so here again if we write exponential x plus r minus 1 cx ln plus r ln p plus x ln 1 minus p. So here this is that ax b theta term. Ax equal to x, so this is canonical, and b theta is actually ln 1 minus b. So that this is the natural parameter.
Actually, b theta is x and ax is equals to ln of 1 minus b. So b of x equals to x. Actually, you have reversed the.
Okay, I see. So here notationally it's a problem. Let me write it down like this: a theta bx. So here we have bx equal to x, so it's canonical, and a theta is the natural. So okay, I understood. This was creating confusion.
Okay.
Okay.
Done.
So sorry. I think I wrote the same thing again. So this is ax into b theta, right? Ax equal to x, and b theta is this thing. All right. Fine. Moving on, this one. So if we have n observations, x's are regressors, y is a response variable. Suppose y is a normal variable, then what is the reasonable choice of fy? So if y is normal, we don't need to make any transformations. It will be y itself. And why so? Fx is how much? 1 by root 2 pi sigma e to the power minus half x minus mu by sigma square. So if we write it as exponential ln of this thing, alright. So this one we can write it as exponential minus ln root 2 pi sigma minus half x minus mu by sigma whole square. So here sigma is actually a nuisance parameter, we are not so much bothered. So if we just expand this part, exponential whatever we have, here we had minus half x minus mu by sigma whole square, right? So here that we can write it as 1 by half 1 by 2 sigma square x square minus 2x mu plus mu square. So x and mu containing term is this one. So if we have something like this, this entire term will become x mu by sigma square. Now sigma square is some constant, ax equal to x and b of theta is equal to mu. So this is in its canonical form, and we are trying to get mu. So
mu by sigma square or just mu?
Mathematically mu by sigma square, but sigma is not of interest to us. Okay, so if you map it to the form that you are using, that a phi term that we had in the denominator, do you remember? There we would have this sigma square. Okay, so this is not the parameter of interest. We are with these formulas, okay, we are trying to infer mean of y, not the variance per se. So here we have a normal variable, the reasonable choice would be fy equal to y.
Okay.
Okay.
Done.
All right. So then I think week 12 is solved. Anything from week 9 or this one? So in just to briefly brush up, week 11 we focused on polynomial regressions. Okay, so any question you need help with?
I'm from week 11. Week 11. Week 11 was. Week 11 of assignments, week 11.
Which one? This is week 11.
Ma'am, the question. Where we have a table of x, y, one is
this one
mapped to 100. Yes, ma'am. Yes, ma'am.
Okay. The least square estimate of beta naught is approximately equal to what? Okay. So if we have this, the main question is to write down the model matrix, X matrix. Okay. So we have X. We should also have, so find out X bar from this table. So that would be 1, so that would be 22 into 23. No, it's not equally spaced, so no, we cannot do that. So just find out the mean. See, beta naught is there an intercept, so 1 will be 1 1 1 1 however many terms. Beta 1 is x minus x bar, so here we have to input x minus x bar. So x bar is how much? Let us just calculate. One plus 2 plus 3 plus 4. How many observations are there?
22.
No, I don't think 22 are there.
Oh.
19 observations are there.
19.
N equal to 19. So a quicker way to do it is, okay, 1 to 16 we have something. So it would be 16 into 17 by 2 plus 18 plus 19 plus 21 plus 22. The answer should be, total summation should be 216. So is this coming to 216? 17 into 8 plus 18 plus 19 plus 21 plus 22. Yes. So this is actually 216 by 19. So this will be something. Let's say 216 divided by 19. This would be 11.37. Let's say. Okay. So here you have to input 1 minus 11.37. So that will be minus 10.37, minus 9.37, so on and so forth. In the second column, we have to input x minus x bar whole square. So this term square. In the third column, we have to input x minus x bar whole cube. So this thing, now once we have this thing, X matrix is ready. We are going to find X transpose X. Then we are going to find X transpose X inverse. and then we'll multiply x transpose x inverse with x transpose y, where x is this model. And if we do that, we'll land up at, I think, option C.
This is a very lengthy question.
This is a lengthy question, yes. But then I think you were also given 2 weeks almost to solve this problem. But I don't think such lengthy questions will come in exams. Even if it comes, yeah, it's unlikely. But even if it comes, I think the problems will be shorter, and some sort of summary metrics should be provided. But I'm not so sure. But usually lengthy questions are not there in the exams. Okay, but this is how you would fit a model. The concept remains exactly the same. Instead of x's, we are just fitting these x minus x bar, these square terms and these cube terms.
Okay, ma'am.
Okay.
Everything was clear.
All right. So this one, least square estimate of beta 2 is approximately equal to, so yes, as I here, how many parameters do we have? Let's say here we have y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon something. So this beta hat will actually, x prime x inverse x prime y will actually be a 4 cross 1 vector. So if I have, so this vector will have beta 1, beta 2, beta naught, beta 1, beta 2 and beta 3. So if I want estimate of beta 2, I should look at the third element. Okay, not the second element. We should, since we are writing it in this manner, x into beta, if we want estimate of beta 2, we should look at the third element. In case the intercept term is not there, then we'll have a 3 cross 1 vector. Then we could have looked at the second element itself. Is it okay?
Yes, ma'am.
Okay. So this is again least square estimate of beta 3. That would be the fourth element. Here, MS residual for the model approximately equal to how much? So SS residual, we know how to calculate. That is actually y prime y minus beta prime hat x prime y. Correct me if I am wrong.
Right.
Okay. So once we have this, SS residual divided by MS residual, that would be n minus number of parameters estimated. So here n minus number of params estimated. So here it would be y transpose y minus beta hat x transpose y by n minus 4. Okay. This one, MS regression for the model is approximately equal to how much? So SS regression will be SST minus SS residual. Okay. So it was actually beta hat transpose x transpose y. Alright. And MS regression, so we have to keep in mind SST equal to SS res plus SS regression. DFs for SST is always n minus 1. For SS residual is n minus number of parameters estimated. So for SS regression, it would be 3 in this case. So MS regression would be this one by 3. Okay, just remember this identity for the sum of squares and also for the DFs. Is it okay?
Yes, ma'am.
Okay, so the last question is this: given that SSS for the model without cubic term is approximately this, can the third order term be deleted from the fitted equation? So here H naught is what? Beta 3 equal to 0. So in order to test that, what we are doing, SS residual of the restricted or under H naught minus SS residual unrestricted or rather full, and here we are testing one parameter, so this would be by 1, and below would be MS residual unrestricted, right?
Yes, ma'am.
So here we have been given the SS residual without the cubic term is this one, 1033.08. From previous we will have this, and MS residual unrestricted also we have. If we see that, okay, so what degrees of freedom will this will follow an F statistic, and what should be the degrees of freedom? It will be 1 comma n minus 4. Okay, so if we see that T observed exceeds F1 n minus 4 alpha, that is that point in F distribution such that this upper area is 0.05, then if T is falling in this shaded region, that is beyond this point, then we'll say that we reject H naught and we'll conclude that no, it cannot be deleted. And if we accept H naught, then we can say that yes, it can be deleted. So if this holds, then the answer is no deletion, but if not, then we'll have deletion.
The correct answer is no.
Yes, the correct answer is no.
And I have marked it yes.
Okay. So
I got it wrong.
So how much did you have your SS residual values over here? Did you get this?
Yes, ma'am. Actually, this topic is weak, so I have just used some internet tools. So that.
Okay, but even if you use internet tools, so
like AI.
Oh, AI. I'm not so sure about AI for that matter. But if you do want to use R tools, I can show you how to do this in R. Do you want me to do that?
Yes, ma'am, of course.
Okay. So let's say I just want this input. Can you tell me what were in order? What were the values in?
Okay, sure, ma'am.
Okay, 1 to 18 we have like this, just as is. 1 to 16, sorry. 1 to 16. Then we have 18.
Then 18, 19, 21, 22.
Okay.
And also, I have 9, 10, 12. 9, 10, 12. 11 is missing.
Oh, I see. So then 9, 10, 12. So till 10 we have. Then we have 12 to
13.
12, 13, 14,
16.
15, 16. 12 to 16.
16.
Okay. So
Then
then
18, 19, 21.
18, 19, 21, 22.
22.
So we have 19 observations. And corresponding Y's are how much?
100, 90, 100, 90, 80, 60, 60, 55, 60, 65, 70, 70, 75, 76, 78, 79, 90, 99, 99, 100.
Do we have 19? No. 100, 90, 80, 60. Okay. Then we have 60, 55, 60, 65. 60, 55, 60. Then again we have 65. So 70, 70, 75, 76. 70, 75, 76. 78, 79, 90. 78, 79, 90. 99, 99, 100. So
Ma'am, which language is it?
this is R.
Python.
This is R.
R.
You can easily download R software from here.
Actually, we have been taught Python.
Alright, okay. So Python requires a little bit of package installation. I find R easier, and it gives solutions quite readily. So I, for that matter, prefer R. But then let us just see how much it's coming to. It will be the same regardless of whatever software you use. Sorry. Why? Very strange. Okay. I'll just proceed to whatever I was saying. Really sorry, I'm not able to join that meeting. I don't know why. So let me just create a new link. Okay, so I'll just wait for really sorry, I have no idea why this has happened. Alright, so where was I? I was just discussing how to solve this. So if this is this thing, and then we have 190, 80, 60, 60, 55, 60, okay, so we did not have 5 over here, that's the reason. So we'll have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Oh, we did not have 11 as well. So okay, so this is x, this is y, and we will have x minus x bar. So let's just write down x bar equal to mean of x, all right, and then let me just write x1 equal to x minus x bar, x2 equal to x minus x2 equal to x1 square, and x3 equal to x1 cube. All right, so this is x bar 11.11, x1 minus x bar, x2 minus x1 minus x bar whole square, and x1 minus x bar whole cube. Now all we have to do is fit our model, which is lm y on x1, x2 and x3. All right, so here we have this model. These are the parameters and intercept terms, okay, and this is the coefficient of intercept, coefficient of beta 1, beta 2 and beta 3. And if we give summary model, we can see over here we see the question was whether we can ignore the x3 terms, and the answer is no, we cannot, because this is highly significant. This is the p value, this is the test statistic value, and since here we have p less than 0.05, that's why we won't be able to remove it. But if we try to follow this calculation per se, then what we need to do is that let us just find out SS regression of the whole model. So to do that, we'll write this thing, okay. If we give ANOVA model, then sum of squares due to residuals is 309.61, okay. So if we come here, then SS residual restricted is this thing 1033.08 minus the unrestricted term is this one here 309.61 divided by 1, and here we have the n minus, that is 18 minus 4. So this is SS unrestricted, that is 309.61 divided by 14. So here we have the mean square formula as well. We can write it as 22.12. so if we try to do this, then how much do we get here? 1033.08 minus 3 09.61. This divided by 22.12. So we have, see, 32.714. There must have been some approximations, okay, to get this 1033.08. So it's close, 32.7. So this is 32.7, and in order to find the Q critical value, we should write QF. Degrees of freedom is 114, and this is 0.05. 114 is the DF, and lower dot tail should be false. Okay. Why is it saying cannot find? Okay, QF. Okay, so this is 4.60011. So F 114 0. So F 114 0.05 is actually equal to 4.60011, and since this T observed is greater than F 114 0.05, hence we reject H naught. What was H naught? H naught was beta 3 equal to 0, and we are rejecting it. That means that we cannot drop, and that's the answer. That can the third order term be deleted? The answer is no. Is it okay? Okay. So yeah, that was all about week 11. Same thing. If we plot the scatter plot, what should be the order of the polynomial? Order should be as low as possible. Okay, that's the only criteria that we have. And if we have something like this, then X matrix is given by this, and then what is the variance of alpha j hat? So variance of alpha j hat is actually sigma square x prime x inverse. So here if we do x prime x, we will only have a diagonal matrix. Why? Because pi x1 into p j x1 would be actually 0. Alright, so this transpose this would be p naught transpose x1, or p0 x1 into p0 x1 plus p1 x1 into p0 x2 into pk x2 into p0 xn. Now since these are orthogonal polynomials, pi cross pj will always be equal to 0. So we'll end up with diagonal terms, everything 0, and these will be p0 x1 square, p2 x2 square, and similarly pn xn square. Okay, so, or in other words, this would be summation pi. All right, so if I just solve it, then I think it will be more clear. So variance of alpha j hat, this we know, variance of alpha j hat is actually sigma square x prime x inverse. Now x prime x is how much? This is p naught x1, p1 x1 to pk x2 this will be x1 as well, okay, and then we have p naught x2 to pk x2, then we have p naught xn to pk xn. This is x, so x prime will be reverse, so this would be p naught x1 to pk x1, p naught x2 to p k x2 and so on. So this is x transpose x. So this into this will be how much? This would be p naught x1 square plus p naught x2 square plus, so if I write it in matrix terms, then this will be p naught x1 square plus p naught x2 square plus pn xn square. So summation p naught xi square I equal to 1 to n. Okay. The next element will be p naught x1 into p1 x1. So p naught into p1 orthogonal, so those will be 0, plus p naught into p2 orthogonal, that will also be 0, plus p naught into pk orthogonal, that will also be 0. So all off diagonal elements will be 0 and we would have p naught and then we would have this like p1 xi square and then summation pk xi square. So x transpose x will be summation p naught xi square summation p1 xi square to summation pk xi square. This is the matrix. So alpha in this case, so we have alpha naught to alpha j, so then variance of alpha j hat will be sigma square x prime x inverse jth element of that. So then in that case we'll have sigma square by summation pj xi I equal to 1 to n whole square, and that is the answer. That is this thing, option B. All right, so I think we have almost covered week 11. Week 10 was more on the dummy variables and we had solved similar questions in the assignments, and week 9 was also about some sort of transformation which was mostly theoretical, and we also learned about weighted least squares and how it's a special case of the generalized least squares. So yeah, I think I have to stop the session now. So thank you so much for joining, and I don't know what happened, why I got logged out, but this recording will be made available to you. So please go through the assignment solutions, and if you face difficulties, then just post it in the discussion forum and we'll try to address that. And all the best for your exams. Thank you so much for joining.